Okay, so what we're going to do now is we're going to talk about section 7.5, day 2. What we're dealing with here is the last of our two trig function graphs. That's going to be our secant and our cosecant graph. So again, this is section 7.5, day 2, secant and cosecant graphs. Okay. So what we're going to be dealing with now is we're going to be dealing with, to begin with, we'll actually start with the y equals cosecant graph. The reason for that is that we started originally by talking about the y equals sine of x graph, so we'll work with the related graph, which is y equals cosecant of x. So here we have y is equal to cosecant of x. It's important to note that since this is the reciprocal of sine, it actually has the same normal period as sine. So typically our period is going to be 2 pi. The same is going to go for our secant graph when we get to that in a few minutes. As far as the amplitude goes, the amplitude on secant and cosecant both, just like tangent and cotangent, is none. Because like tangent and cotangent, the graph of secant and cosecant is going to zoom off to positive and negative infinity. So there is no maximum or minimum value for us to do maximum minus minimum divided by 2, which is the actual equation for finding the amplitude. What's important to understand, guys, is that since cosecant is the reciprocal of sine, we are actually going to use y equals sine of x as a guide curve. And then we're going to use that to actually draw the cosecant graph. So let's do that right now. Let's start with our y equals sine of x. So again, our period is 2 pi. We cut that in half, which is pi. We cut that in half again, which is pi over 2. 1 pi over 2, 2 pi over 2, 3 pi over 2, 2 pi. Now, remember, sine goes between 1 and negative 1 because while cosecant has no amplitude, sine does have an amplitude. The amplitude is 1 since we're dealing with just plain old sine x on this one. The idea is that we are going to do all of the transformations in our cosecant equation to our sine curve with one exception, and that is the vertical shift. We'll talk about that in a little bit here. So this one has no transformation, so we're just going to have beginning, middle, end, maximum, minimum. And we're going to draw our nice smooth sine curve. So there's y equals sine of x. There are no transformations to worry about. Here's the idea now. Just like tangent and cotangent, there are going to be asymptotes on our cosecant curve. Because stop and think about this. Cosecant is the reciprocal of sine. It's 1 divided by sine. So that means that here, here, and here, anywhere where sine is equal to 0, cosecant is going to be 1 divided by 0, which is undefined. And so what that means is that we are going to end up with asymptotes here, here, and here. Because those are the places where sine is 0, and so cosecant is undefined. So you want to make sure you draw your asymptotes in because those are going to be your guides, and we're now going to use the sine curve to help us guide the actual cosecant curve as well. Now we don't need to worry about 5 guide points. All we need to worry about for cosecant is we need to start right at the maximum, wherever that is, and we need to open upward towards our asymptotes without touching them. Likewise, we're going to start at the minimum, and we're going to go downward. And so this ends up being 1 period of our cosecant curve. So again, red is our final graph. That's our basic cosecant curve. Again, the period is 2 pi. The amplitude is none because we zoom off to positive infinity here, negative infinity down here. And it's important to understand that when you're graphing this, 1 period constitutes 1 upward opening curve and 1 downward opening curve. And you'll see when we get to secant why I'm really driving that one home. Okay, so that's our y equals cosecant of x. Now what we're going to do is we're going to look at a slightly more complicated one. We're going to take a look at one with some actual transformations in it. So we have y is equal to 3 cosecant of 2 times x minus pi over 4. Let's make that 4 look a little bit better. There we go. Okay, notice first of all that our b, our period adjustment, has already been factored out. So we don't have to worry about factoring it, but you always want to check that first. What we're going to do is we're going to use y equals 3 times sine of 2 x minus pi over 4 as our guide curve. We're going to graph that, and then we're going to use that to put in our asymptotes and draw our cosecant curve. So let's get this going. We have this. Notice that we have some transformations. Here our amplitude is equal to 3. Now this is our sine amplitude, not our cosecant amplitude. Okay? The cosecant amplitude is again none. Notice this 2 is our period adjustment, so we know that our period is going to be the original period 2 pi divided by 2, which is equal to pi. And so again up here, our period is also going to be pi. This is going to be a phase shift of pi over 4 units to the right. Notice there's no vertical shift on this one. We'll get to a vertical shift in a little bit. The reason I left it out of this is I want to just emphasize that all of these get done first. The vertical shift is the absolute last thing that you do. I mentioned that when we started this process of graphing these. It's the absolute last thing that you do. It's not the second or third or fourth. It's the last. Because if you shift your guide curve up or down before putting the asymptotes in, then what's going to happen is your asymptotes are going to be in the wrong places. We'll talk about that in a minute. Okay, so we're going to go out here to pi. That's our period. We cut it in half. There's pi over 2. We cut it in half. There's pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Our period is going to be 3. So I'm going to go up to 3, down to negative 3. This is the sine curve. So beginning, middle, end, maximum, minimum. Draw in your parent function with the proper amplitude and period. There we go. So that takes care of the period. That takes care of the amplitude. The only thing left to take care of now is our to the right pi over 4. I'm going to switch to green to do that. Notice pi over 4 is one of these units. So we're going to slide this to the right 1 unit. We're going to slide this to the right, slide this to the right, slide this to the right, and finally we're going to slide this to the right. This is pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. This would be 5 pi over 4. And so now this is our sine curve with all of our different transformations accounted for. So the green one is the one we're going to use as our guide. So now we're done with all the transformations. Now we can actually convert this into the cosecant curve. So remember, anywhere where our sine is 0, we're going to have our asymptotes. In this case, at pi over 4, at 3 pi over 4, and at 5 pi over 4. Those are our asymptotes. We're going to start at the maximum, and you must actually touch the maximum point. If there's a gap in there, or if there's some overlap, I'm going to dock you guys points because that's not correct. It has to start at the maximum and open upward towards its asymptotes. It starts at the minimum and opens downward. All you need is that one guide point. And there we go. So the red one is our final graph. That is y equals cosecant of 2 times the quantity x minus pi over 4. Pretty easy. All right, let's take a look at one more example. We'll take a look at a secant curve now, which is related to cosine. So now we're going to use cosine as our guide. And we're also going to look at a vertical shift here, so I can talk about that. So let's use y is equal to negative secant of parentheses pi over 2x minus pi over 4 minus 2. So the first thing that we're going to do here is we are going to work with y is equal to negative cosine. I have to factor the pi over 2 out. We've talked about that before. When I divide pi over 2 out, I get x minus, and when I do pi over 4 divided by pi over 2, that becomes pi over 4 times 2 over pi, which becomes 1/2. We've seen that example before, minus 2. All right. So there is our guide curve. So we're going to use this one as a guide. So notice that we have an x-axis reflection. Notice that our period is now going to be 2 pi divided by pi over 2, which is really 2 pi times 2 over pi, which is equal to 4. So that's our period. We're going to shift to the right 1/2, and we're going to shift down 2. And this is going to be the absolute last thing that we do, which means we're not really even going to do it on the cosine curve at all. When I say it's the last thing we're going to do, I mean it's the last thing we do before we move on to the next problem. We are going to take care of this when we actually create our secant curve, and that's very, very important, and I'll explain why. Okay, here we go. Our period is 4. Actually, let me make this a little bit smaller. Let's put 4 here. Make it a little easier to draw. Half of that is 2. Half of that is 1. 1, 2, 3, 4. Our amplitude for our cosine curve is 1. So we're going to go between 1 and -1. But remember, for secant, our amplitude is really none because it zooms off to positive, negative infinity. Our period here is going to be 4. Cosine begins and ends at the maximum. Halfway it's at the minimum. In between it hits the x-axis. Here is our basic cosine curve with the proper period and amplitude. So we took care of period. We took care of the amplitude, which is built in. It was just 1. Now what I would do is I would take care of the x-axis reflection. So I'm going to switch to green. 1 reflects down to -1. 0 stays at 0. -1 reflects up to +1. 0 stays 0, and 1 reflects down to -1. And so now we have this as our cosine curve. So we're going to work with the green one now. So that's our x-axis reflection. The next thing we have to do, and I'll switch to blue for this, we now have to do to the right 1/2. Notice a half is half of one of our marks. Here's a half. So it's halfway to our first mark, which is 1. So we're going to shift this to the right half of one of our units. We're going to shift this to the right half. We're going to shift this to the right a half. We're going to shift this to the right a half. And we're going to shift this to the right a half. And so now we're looking at this curve. And I know it gets a little confusing with all the curves. But again, if you're using colors, it makes life very, very easy to see where each curve is. And that's what I'm looking for from you. Okay, we are now done with these 3. Now what we're going to do is we're going to convert this into our secant curve. Again, we have not done the -2 yet. That's the absolute last thing that we do. So what I'm going to do is I'm actually going to switch to yellow now. And my asymptotes now are going to be anywhere where cosine is 0. That's where secant is going to be undefined, which means right here and right here. I actually should extend these up a little bit further. This one was a little bit short. So remember, we're talking about the, we're talking about the blue curve. Excuse me. I apologize for that. We're not on the green one. We're on the blue one because we shifted to the right 1/2. Let's fix that. Sorry, our asymptotes are here and here. I apologize. There we go. So we're looking at our blue one. Here are the asymptotes. So we know that we're going to start at the maximum, and secant is going to open upwards out towards its asymptotes. Now, for the downward, we start at the minimum, and we open downward towards the asymptotes. But notice we have not graphed the asymptote on the other side. There is one, because this keeps repeating. So notice it only gives us half of a downward opening piece. We could go farther and draw the next asymptote in. But there's no need to do that. We can just go over to the other blue minimum over here and draw this piece in. notice that what you get is one continuous upward opening piece, and the downward opening piece is broken into two pieces, a right piece and a left piece. That constitutes one period. We have now graphed a full upward opening section and a full downward opening section. This is perfectly acceptable. If it bothers you to draw those two, then what you would have to do is you would have to go out, you'd have to go another unit to the right. So we would have 5 over here. And so we'd have to go from 3.5 to, I'm sorry, we'd have to go 4 units to the right, excuse me. 1.5 to 3.5, 2 units, excuse me, I apologize. We'd have to go 2 units, which would put us at 5.5. This would be our other asymptote. And then this would open downward like that. But there is no need to do that unless you feel that it makes you more comfortable. Personally, I would just leave it the way it is, because then we're just graphing the piece of cosine that we're used to graphing. All right, I apologize for the confusion there. All right, now we're not done. What we have done is we have done secant with all of these transformations. What is left is the -2. So now I'm going to switch to red, and now I'm going to have to shift everything down 2 units. So this is at 1. It's going to shift down to -1. It's still going to open upward towards its asymptotes, though. Sorry, my tablet froze there. This is going to move down to -3, and it's going to open downward still towards its asymptote. This one is going to move down to -3, and it's going to open downward towards its asymptote. And what I would do is I would just draw these in red, because these are still the asymptotes for the red one. Because the thing is that when we take a vertical asymptote and we shift it up or down, because asymptotes are lines that go on forever, it doesn't change. It just slides up and down and continues the way it was before. So I know it's kind of hard to see, but the red one is actually our final graph. And even though this is very confusing looking, if this is how you show it to me, I can see exactly what you did, and I can see that you did it correctly. Just make sure to indicate which one is your final. Now, what I want to talk to you guys about is the problem that occurs if you do the down 2 prior to converting to the secant curve. And so here's the issue that you run into. And that is that if you have, let's just use the sine curve, just because it's nice and easy to draw. So here's a sine curve. Notice that this would give us asymptotes. If we were looking at cosecant, this would give us asymptotes here and here and here. So this would just be our y equals cosecant of x. What we're going to do is we're now going to do a +1. So we're starting with y equals sine of x plus 1. And if we do the +1 here, then what ends up happening is this. Watch what happens when I grab this. Let's actually put a unit here. There's 1. There's 2. There's -1. Watch what happens if I grab this curve and I slide it up 1 unit. Actually, that was a little bit off. Let's try and get it a little bit better. Notice what happens, guys, that this, and this no longer are our asymptotes. Because where sine is 0 is where cosecant is undefined. So now our asymptote would be sitting over here. But here's the issue. That is not correct. It can't be correct, because this has absolutely nothing to do with cosecant of x. Cosecant is undefined wherever sine of x, cosecant of x is undefined wherever sine of x is equal to 0. That 1 gets added on after we've already taken the cosecant value. We add that 1 on after we will have already divided by 0. So there's no way this can have any impact on it. Let me give you an example. What if we were graphing y equals 1 over x? Clearly, we have a vertical asymptote at x equals 0, because if we plug in 0 for x, we don't get a y-coordinate. It's undefined. If I put a +1 at the end of it, does that now mean that our vertical asymptote is at x equals 1. Does that now mean that if I plug 1 in for x, y is undefined? No, of course not. 0 is still what causes y to be undefined. The plus 1 has nothing to do with the fraction. The same thing is going on here. The plus 1 has nothing to do with where cosecant exists or doesn't exist. All it is if we do get a value for y from cosecant, we're going to add 1 to it. So I hope everybody sees that. So that's the issue. This is not where you want your asymptote. You want your asymptotes here. And so what you want is you want this guy to be sitting where we originally graphed him. You want these to be your asymptotes. You want to draw these in prior to the shifting up 1. And then you want to take this and shift it up 1 unit, and take this and shift it up 1 unit, and take this and shift it up 1 unit, and take this and shift it up 1 unit. So that's what you want to do. Now the other thing you want to avoid is, remember that we're shifting up 1, which means both red pieces go up. You don't move the upward opening 1 up and the downward opening 1 down. So this doesn't move up to 2 and down to -2. It moves up from 1 to 2 and up from -1 to 0. So be careful with that. I see that mistake quite often. All right, so that is our cosecant and our secant curves. Hopefully that will get you guys through the assignment without too much difficulty. And we'll go from there.